Good, great. Thanks for the, where did he go? Introduction, Alexei. Thanks for the invite. And wow, thanks for coming out. I should have poured a beer instead of some water or something. That's a lot of people. These are not the classic Scala stairs, but if you ever have a chance, go see the Sauvablin Tower in Lausanne. It's made of wood and a couple of screws here and there, I think. It's pretty cool. Anyway, so I don't have discounts for trainings right now, but I do have something that's almost as good, maybe even better, probably more fun. So Scala Days in New York this year. It'll be mid-June, and if you write that down or Google this thing, I'm sure Google has indexed my slides by now, so you can, along with everybody else out there, get a nice discount. I just want to show you the website real quick. It's kind of dangerous when you go to it because you're bound not to come out as soon as the Wi-Fi wants to work with me. Maxime, our designer, did a great job. We just finalized the program, so not during my talk, but have a look and sign up. So in addition to thanking the hosts and the organizers of the meetup, also really like to thank our contributors. A quick link to GitHub here. So we have this will give you the top 100. And this is about a decade worth of contributions to Scala, and you definitely see, I don't know what happened here, but there's like a spike in commit traffic. Oh yeah, that's Typesafe. So there's a lot of you in the room maybe even that are in this list, so thanks a lot for your contributions, for your issues that you've reported, for your mailing list, for your kind answers. Yeah, I'm not going to read those numbers, but I'm very excited to see that, and we're hard at work making sure that our infrastructure can deal with all those pull requests. So I also like controversy, and I'm going to start with, well, maybe this isn't controversial, maybe it is. I'm going to say Scala is simple, and I'm going to give you evidence to the contrary during this talk, and then I'm going to refute that evidence, and I'll try to kind of come back to my claim. As it goes with controversy, feel free to disagree, interrupt, yell out questions. You know what's at stake. Yeah, comments. It doesn't even have to be a question. I don't care. So I'm going to do my best to make it super interactive. I'd really appreciate whenever stop me when it's not clear or hit the fast forward button when I get into a rant or something. So I'm serious about this, and we spent a lot of time thinking about this. There's a lot of surface area around Scala, but we feel it all comes back to a nice, elegant core. And that's because Scala is a unifier. We didn't just tack functions onto Java. We figured out how to fuse functions and objects together and figure out what the right scales are for these abstractions. And I think that's kind of the theme in learning Scala is when is it appropriate to use a function? When is it appropriate to compose traits? When do you mutate? When shouldn't you? And that's definitely a challenge for the community and for us as educators to explain that better. And I think a lot of the confusion about complexity comes from making these choices. So it also unifies experimentation. I don't know, just curious, who's used to Scala REPL before? See, yeah, that's what I thought. Yeah, I love the REPL. I think that's just great. And the same kind of code that you write there, the same compiler that you're running, you can do large scale development with that as well. And I think that's another nice unification that's often forgotten. So I'm going to venture into demo territory. Wow, that looks pretty small. Can you read that or no? No? Do you mind if I just quickly kind of, I even learned CSS for this talk, can you believe it? So, oh, I would claim that's true, yes. Because now I have to kind of grep everywhere and figure out where the font size is for that thing. I'm pretty sure I looked it up before. Maybe it's here. Yeah, there we go. So like I said, I'm going to hit you with my CSS book that I don't have, so don't worry if you ever claim that Scala isn't simple. So see? Almost feels as good as fixing a bug in Scala C, I have to say. Anyway, so let's print some stuff. To prove that this is not scripted, I'm just going to take a suggestion, and this counts for the book. If you have a good suggestion for my print line, you may win a book. So what should I print? Nothing. OK, nothing. That's too bad. You had your chance, but not going to win anything. Right? So this thing is sending shit to the REPL. And the REPL is doing its thing with it and sending it back. I also learned WebSockets this weekend. It was great fun. So that's what I'm going to be doing during this talk. And if anybody has questions about Scala, I'll be happy to address them in this little box here if you want to try something. Or no, not so much. OK, that's what I thought. Great. So behind the scenes, I'm using unfiltered because that's the first Google hit that I got for WebSockets. And then I copy-pasted some deprecated code. The WebSocket server is apparently deprecated, but I couldn't figure out how to do it better and shorter. So you open a socket, you get the REPL, and you pass a partial function to the WebSocket constructor, which is defined using a pattern match here. There's no match statement because you're just constructing a partial function literal. And I just showed you two cases. There is a closed case, but it's not super interesting. So you can open a socket. You can receive a message which has some text. And then I interpret that text and send it back to all my sockets. I don't really care about security of any of that. It's running a localhost. What could possibly go wrong? Oh, yeah, no, that's what's going to go wrong with increasing your font size. OK, so this is the interpreter part.
Adriaan,
yeah.
can you change the color of your keywords?
I'm glad you asked, Jamie. I didn't. That's an excellent question. I'm pretty sure I can do that. I've been. Yeah, that's in default.css. I love those names. Keywords. What color would you like?
White.
White. That should do it. Well, it's just white. It's not very inspiring. I spent so much time tweaking all these colors. No more color changes, OK? So I know I said you could interrupt me whenever, but I take it back. So we're going to interpret the data we get in is just separated by a colon. So we're just calling into this Java function that's going to give us back an array. Doesn't matter. We can also pattern match in arrays. I want the first thing before the colon to be run, and then I'm going to put that in a variable. That's going to be my source code that I got from my JavaScript on the server. And I use server very loosely. It's just on the client. I mean, sorry. And so I'm going to redirect the output stream from the interpreter, and I'll make a string out of it, and that's what I'm going to send back. You might also notice some funky pattern matching going on around here with regexes and string interpolation. That's new in 2.10, and it looks crazy. I'm going to explain it later. Any questions so far? Any other caller requests? No? All right. So there's links on the slides to the full code, and so I won't bore you with that. But so this is just calling into the Scala REPL that's part of the Scala compiler jar. In 2.11, it will be a separate jar because we're kind of working on slimming down our jars. So I'll come back to this. Since I promised you could interrupt me at any time, I kind of have to hedge my bets and tell you everything about Scala 2.10 in the next 5 slides, and then we'll just kind of go off and rants and tangents and so on. So I'll just give you the list. You probably read it yourself. So the rewritten pattern matcher, I had a lot of fun doing that last year. So I basically just threw it all the code and started from scratch. Well, actually, first we started, and then like in 2.11, now we've thrown out the code. It's still in 2.10 if you want it under xalt patmat. String interpolation, I'll talk about that because I think it's really neat the way we did it. I won't talk about value classes much because I don't think it's very neat right now. But I'll take questions about it if you insist. Implicit classes are great. Feature imports, allowing you to kind of trim down the subset of Scala that you're using in your project. Beginning Scala programmers might not want to define implicit conversions all over the place. It's really cool that you can use ints wherever you were expecting a string, but maybe, you know, should be programmed in a different language if you want to do that, CSS or something. I don't care. Futures and promises, awesome. I know a lot of you who are actually doing, you know, the amateur coding I was doing this weekend rely on that for scaling. We have dependent method types that me as a type theory geek really likes, and you can bake cakes with that really nicely. And we switched to ASM instead of our hand-rolled FJBG that is, well, we kind of know you too well. And then there's some experimental stuff. Actually, the first bullet isn't experimental, but it's really cool to experiment with, so I kind of put it in this category. Reflection is experimental. Everybody, did you hear it? It's experimental. I mean, I really like that you're using it, but we're probably going to change it. We're going to fix stuff in there, and same thing with macros. So I love macros. I think they're great. I was very skeptical from the beginning, I have to say, but I think people have been doing a lot of cool stuff, and we're still thinking about how to do it just right and just the Scala way. So don't bet the house yet on macros, is all I can say. There will be some kind of macros. I think that's pretty much for sure. So yeah, like I said, rewrote from scratch. A lot of long-standing bugs. I'm sure people using Play or Unfiltered have seen the exponential bytecode explosions when you nest. Yeah, did you see them, or do you have a question? Sorry? Why do you need reflection? Oh, that's pretty philosophical. Well, so reflection is really about turning your program into data, like, you know, what Lisp kind of does without even mentioning as a separate thing. We like to reflect over our stuff because we're, you know, kind of all philosophers as programmers. So I'm sorry, I really want to give you a practical answer. Can you elaborate a little bit on Yeah. So for example, this talk. Oh, pattern matching. Well, you pattern match on the structures you get back from reflection, but you can't really use pattern matching until you have an object in your hands, right? Reflection gets the thing from meta to base level to data so that you can actually pattern match on it. Without reflection, there is no way to go between those two levels. So reflection is your handle on kind of what's out there around you, that you, like the ether that you can't touch if you don't have reflection. And then you get reflection, and suddenly you can say, hey, here's a tree, and this is actually a tree that's in my program. So usually you can't really like reason about what line number you're on, or you know what like the tree of your argument looks like. You get the value that the tree evaluates to, but you don't get to see the tree. With reflection, you can reason about all these things, right?
So I feel the confusion is that you're talking about tree reflection, and most people understand it as Java reflection, where...
Okay, yeah, so I mean, it's like Java reflection, but kind of to the max. So it exposes the compiler API to you, essentially. So you get to see all the same data structures that the compiler sees through a slightly simplified lens. Yes?
Does that mean you can do AOP with it?
It's only, you can only look. You can use bytecode. Sorry? Yeah, I mean, the bytecode has been compiled already, so I mean, you can use all the stuff that you would, I mean, you could use it to write your own AOP engine, but the actual bytecode rewriting we don't do that for you. We just give you a way to say like, hey, are these types subtypes? Hey, what's in this tree? Create a new tree, type check it, stuff like that. So you can do everything the compiler does, except if you want to write it to disk, you'll have to do that yourself. Sorry, that's not what reflection is about. If you want to change those class files, you know, that's the Java platform. That's why we love Java, right? We have all these facilities for us that we don't need to do that. Does that answer your question, or yeah? Okay. Okay, I was just buying some time to think of an answer. I'm sorry about the kind of slow start there. Pattern matching, right? So exponential space blowup is one of my favorite bugs in the pattern matcher. You write a really innocuous looking unapply, or actually you don't even see the unapply, you just write a pattern on lists, and all of a sudden you run out of bytecodes in your method. And people get really confused about that, and there's a lot of, you can Google it and you can find a lot of hits about that. So that's fixed now, so don't worry about it. I saw Unfiltered has some complaints about that in their docs, but if you're running on 2.10, it's not a problem anymore. And the implementation is actually something that we understand now and are actively working on improving it in 2.11, doing some neat stuff there. OK, so what kind of is new in the pattern matcher is that extractors, which are those unapply method calls that we'll see in a second, they're now also subject to enrichment. I can't say the other thing anymore, you know, like the MTV show about rides and making them pretty. So enriching methods is something that you can do also in patterns now. And we'll put that to good use later. I'm sorry if this is not making any kind of sense. I'll have an example of that later. And we're using a little sat solver in the pattern matcher to give you really nice error messages of when you match on something. It says, hey, did you think of this case? Or this case is never going to be hit. I'll also have some examples of that. And if you want to do really crazy stuff, you can virtualize your matches, and you can kind of reflect on your match. But I won't go into that in this talk. But if that's kind of the kind of stuff that you like to do in the weekend, I would click on that link and play with it. So pattern matching can be quite exhausting, and you know, especially making sure that you covered all your cases exhaustively. I just love puns. So when you run this, actually it's going to crash, but you can't see it because someone made me increase the font size. Probably can do something like this. No. Oh no, it's not going to crash because I actually don't run it. I'll make it crash later. So the compiler is actually saying, hey, dude, the match is not exhaustive. What happens if you pass in a none? So first of all, this is familiar syntax to everybody, right? You would have stopped me if it wasn't. OK. So let me see if I can navigate in this thing. Right. So check none, because this is one of the counterexamples that the set solver came up with for you know, not crashing. So let's try and see what happens. Oh, shit, yeah, now we get a whole other kind of problem. So luckily, I can still scroll around. So yeah, you get a match error, because we weren't anticipating getting a none. I'm sure you've seen this if you've used pattern matching in non-trivial cases before. So I'm just going to clear that box, good thing that's in there. And we'll just handle that case as well. And now we're all good. OK, it may still fail because you're not handling all kinds of thingies in sum. So what's the last bit? And this doesn't count for a book, but if you get it right, I'll be really happy. So what is the missing case here? I'll give you the case for free. Are you sure? Let's see. Yes. Great job, everybody. Yeah, so that's exhaustivity checking for you, the pattern matcher. And so just let me take a moment to come back to the theme of the night here, is that Scala is a unifier, and then the thus simple is kind of my theorem. Because if you unify everything together, it's kind of like this very small core that you need to understand, and everything kind of generalizes from that. So extractors reconcile pattern matching, which people in the O community in the beginning were like, why would you want to break encapsulation just to be, you know, conveniently look at lists? Who does that anyway? I mean, just, you know, write a for loop or something. Don't forget to increase your counter. So, well, the research that was done at EPFL where Scala was developed came up with a nice idea of implementing extractors, which let you configure the way that you actually decompose the stuff that you've composed. So, you know, constructors let you make data, extractors let you unmake data, really. So they're kind of the dual. Extractors return options because they might not match, and that's what you use option for. And that creates overhead, but we have some thoughts and very concrete thoughts on how to fix this with value classes that I'm not going to talk about unless you make me. And we'll do that in 2.11. Yeah, we also have an idea how to fix that. So actually, tuple boxing doesn't necessarily happen when you pattern match on a case class. We just go directly to the field accessors of the case class. And we want to generalize that mechanism that you can supply your own field accessors that are used for pattern matching, so you don't have to put stuff in a tuple only to then just decompose the tuple again. And roughly the same thing for options, except that there you really need to say yes or no, so you use value classes to get rid of the overhead of the option box. So kind of a neat way to define an extractor is, well, really all you need to declare your own pattern. And I stands for integer. Just try to make it, it's a good thing. I was anticipating font increases, so I didn't use too many tokens. So when your value I has a method unapply and it takes a string, for example, and returns an option of int, it can be used as a pattern. So what this match here really amounts to is saying, hey, I.unapply 10, now match on that result. If it was successful and it was a 10, then we're all good. So this allows you to kind of hook in and kind of intercept, really, like it's kind of AOP in a way, the matching mechanism and say, no, compiler, this is what I want you to do, not whatever stupid logic you have, which in this case would say, hey, this is not a case class, right? So util.try is based on work by Twitter that we're pretty happy with, so thank you, Twitter, for contributing. And yeah, I don't know, we can just run this stuff or take questions about it, make it crash, or yeah, so again, we're not fully exhaustive, obviously. Questions? Anything? No.
Is Twitter a main contributor to Scala at this point?
No, I wouldn't say that. We enjoy working with them for making sure that futures, for example, that we were using fit well with the futures that they are using, and the same for try. But I wouldn't say they've contributed usage. They're one of the really early adopters, and that's been great for us. But I would say that's roughly the main thing.
Is that a large percentage of their backend, Scala?
I'm not. So when they went from fail whale to non-fail whale, that's kind of roughly coincides with the switch to Scala. Just kind of, right? I mean, I'm allowed to say these things. Okay, so that's kind of roughly all I have to say about pattern matching, simple stuff. Now, string interpolation. Who's used that before in 2.10? I guess some people are using 2.10. Okay, a couple people, so not everybody will be bored with this. Okay, great. So let's say you want to create a string that says how many bottles of beer you have on your wall somewhere. And you write a first version that just takes any string and it plugs it in to another string. So what this does really is say, hey, use this simple string interpolator, take a variable called n and just plop it in here instead of the variable. Then someone else comes around and is like, no, that's really unsafe. You might say no bottles of beer or something instead of 0. We can have that. So I want an integer. So I'll write $n and then %d, which is the printf formatter. So you have an f string interpolator. I'm just going to call it interpol if that's OK with everybody. It's too complicated. And actually, the cool thing about this is that the compiler will actually say, hey, this has to be an integer. And in this case, luckily, we supplied one. So here, the compiler is going to say, nope, can't do that. And I'll prove it to you if it fits on the screen. Right, so the compiler says, oh, you gave me a double A, sneaky, sneaky. I was expecting an integer. And it's actually not the compiler who's saying that, which is the cool thing. It's a macro. And I'm kind of going to work my way to explaining how this mechanism works. How does string interpolation work? Well, you drop those $prefixed, let's call them holes in your string. Those are becoming variables. Pack the other parts in a string context, which is a case class in the standard library. And then call the interpol thingy, which is named in the prefix by whatever is SF or whatever you want. It's not built into the language. That's how we keep it simple. If you want to add another one, I'll show you how in a couple minutes. And then those holes are passed as arguments to that thing. So you're free to do whatever you want with it. So it's a good thing these things are editable. So what the compiler generates for you, or desugars this to, is, hey, create a string context. This is what's left before the first variable you want to interpolate. And this is the rest of your string. .s, which came from what you can't read up there in the conveniently colored comment. And we defined that with the prefix to the string, and then whatever we wanted to pass in this case, the variable n, but you can really put in anything. And somewhere in the standard library, we gave you a couple of string interpolators for free, and you can buy more from Typesafe. No, I'm kidding. Yeah, you can implement them yourself. And so the S one is standard, and you can just call it directly. And that's all there is to it. See some puzzled faces, some like, yeah, I do this all day. Questions about this?
Why is it important?
Why is it important? Why is string interpolation important? Why is the sugar?
Why would you use this? What's the point of it?
Okay, sure. That's totally fair. And that was our position for the last decade, roughly, until 2.10 came around. And Martin figured out a way how to do this, the Scala way. And before, we were writing stuff like, oh man, could someone explain to me why this cursor doesn't work? Oh, JavaScript, why do you mock me so? So we would have this convention that you would just write n plus and so on, right? And you can do that. I mean, just think away the rest. I noticed myself writing error messages, for example, and I'm sorry about that. Some of them are crappier because it's just a pain to compose strings with plus. Sorry?
You use a format.
Yeah, so you can use a format. So you can write all your stuff first, and then make sure that everything matches up with the format that comes after it. And you don't see what expression goes into your format. So, oh, was I going to explain about the tree and then the type, or the type and then the tree? Or was it, and then you, no, it's just, I just want everything together. When these things are there, I think it's great that you can see the string as it's going to be, as a prototype of what it's going to be right there in your code. You get completion in the IDE because those holes in there are actually expressions, so that all integrates seamlessly because this rewrite is happening behind the scenes, and IDE knows about rewrites in general. So it'll just give you code completion on that. You can write your own interpolators. Yes? You can, so those interpolated strings are first class, so you can abstract over them and put different languages in there. Yeah, good question. Yeah, that's definitely important. Yeah.
Thank you.
Okay, I'm glad I could convince you. From now you're like in the lead for the thing. It's edging towards you.
Let's get into the data structure.
Yeah. Well, there you'll definitely beat me because I just n square my way through everything. Oh, sorry, I didn't see that.
Yeah, isn't there a run when you do this and it's a call by value, then you don't have the overhead cost of actually calling and interpolating the string unless you actually log. So if you're doing string interpolation here and you're always doing that, you're always interpolating.
No, because you're free to define that method no matter how you would like. You can make it a macro and not emit that code at all based on compile time decisions. You can make it a call by name argument and do the same thing as you would do in your normal logging framework, where you just don't invoke the closure and cross your fingers that hotspot will say, oh, he's not calling this, it'll be good. Is that what you're saying, or? Okay. Yeah, so that's, I think, pretty much all taken care of. So, for example, the formatter, the printf style interpol thingy will actually compile to format. So there's a macro in the standard library that does the standard printf style type checking. So it'll infer the types from the format specifiers and checks that you have enough arguments, and then compiles it to an optimal format blah call that you should never write again. Okay, and I'm not going to go into the macro details unless you make me. I have a link right there. It's really convenient if you want to see it. But again, this is not. There's very little magic going on here. It's just another macro call, and you can implement your own interpolator with a macro and do the same thing. Macros are experimental, though. Saying. Yes. You mean in the implementation of 2.10, how many macros are there? None. Unless I'm mistaken, Greg. No, there are none. Yeah, so but those are part of the standard, oh, sorry. So yes, part of the standard library, there's a couple macros that you can use, but to actually build the compiler, like the compiler itself doesn't use any macros. I thought that's what you meant. Yeah, like, okay, the macro implementation uses macros itself, but if you don't touch macros, the compiler won't use them gratuitously. That, I think, is a precise statement. Is that what you meant, or?
Well, I was actually asking about the library as well.
So yeah, there's a couple of these in the library, and mostly they're in the experimental stuff for the macros themselves. That is basically just a large suite of macros to help you deal with. So there's a core. I don't want to turn this into macro talk, mostly because I haven't done much with macros myself, to be honest. But there's this core abstraction which lets you go from meta to data, which is called reify, and then everything else around it is just implemented on top of that as macros as a library. So reify and eval, it's just like splice and unsplice and other macro languages. Yeah. So, but we don't really. There's a couple of things like this in here when it's not mission critical. We were happy to experiment with that, but since macros themselves are experimental, we didn't really. Yes. Yeah, so that's coming next generation. So there's a ton of stuff, like Slick is not part of the distribution, that's something that we're developing now. Scala Async, I mean, there's a ton of cool stuff being done with macros. It's even on top of 2.10, so not necessarily for the next release, but it's not technically part of the core distribution. But so Slick is the database access API that we have. And Scala Async is a cool way of getting rid of not having to deal with for comprehensions when dealing with futures, and just kind of write in direct style instead of monadic style. That's also based on macros, so you don't have to use the CPS plugin anymore, thank God. Sorry, Alexi. Yes, but no, macros are experimental. That's the official stats. Okay, thank you. Okay, so now I just kind of want to go all crazy with this and show you what you like, the extent you can take this to. Just because on our way to implementing this, I'll show you implicit classes. I'll show you kind of how the pattern matcher works under the hood. And these are like the new features in 2.10. So let's say you kind of want to do the reverse. So you have this string and you want to decompose and find how many bottles are in there. So before we wrote this interpolated string, and this is going to be R for regex, which is not part of the standard library, so we're going to implement it ourselves, and we're just going to we want this to become a pattern that says any number of digits, could be 0 actually, maybe I should have thought about that a little bit longer, and then we're just going to match to OK. So is the intent clear of what we're trying to do? All right. You may disagree with something like this. I'm just kind of using it to illustrate their actual bigger kind of data structure that you might want to decompose this way that make more sense than regular expressions. So in general, what it means to be first class means that you can be stored in a variable and passed around. So functions are first class, which means they're just objects. You just put them in a variable, pass them in as an argument, doesn't matter. Scala is simple like that. You don't have to think about limitations like, can I put that there, or can I put that there? Can I nest this method in there? Sure you can, it's all regular. Don't memorize all these exceptions that you have to deal with in a language that restricts you to first order. So the higher order thing, in my opinion, is part of the simplicity story where you say, well, don't worry about abstracting over stuff. We'll let you abstract that. It's not just the simplicity, it's also a matter of power of abstraction and actually decomposing your code base that way. So I can just rip this pattern out, put it there, and I'll come back to the slide to prove it to you once we've implemented all of this and run it. So you can tell I'm totally making this up. And now we're just matching on this pattern, which won't return any data because it just says yes or no. Does that make sense? Question?
But you actually evaluating it. It has parentheses at the end. It's not the same.
Well, yeah, that's a minor nitpick. I actually struggled with that myself, to be honest with you. The pattern syntax, what I should have written here was the empty parens after that, but it looks really ugly. And there is I think I would classify it as a bug that we didn't require those parentheses back there. Scala will, as you know, infer for you that you forgot like the dummy like empty parentheses. And it's a little bit stricter about that in patterns because we didn't used to do this kind of stuff. And so here it says, hey, that's an identifier. I am expecting parentheses because you don't. Otherwise, it's not going to look for. The technical reason is it won't look for an unapply if it doesn't look like an apply. Yeah, sorry.
Can you extract a member instead?
Yeah, you can. Yeah, definitely. Yeah. So, and that would have been nicer because that way I wouldn't have fallen into that pitfall. I'll show that. That's kind of going to be the culmination of my rant here to show you how you could do that. And keep in mind that regular expressions is just an example that fits on a slide. I'm sure you can think of JSON, XML, actual source code as quasi-quoting, where you like to pattern match on these things and just immediately, just like with string interpolation, when you're constructing data, you want to see how everything fits together rather than in different parts. You also want to see that when you're decomposing. Okay. So the idea of figuring out how to do this when you're hacking this kind of weird stuff is like, okay, well, if this works, I know how to make the previous thing work. So let's proceed by induction. So the desugaring that I showed you before for the I extractor, where really what you're doing is on the selector of the match, you're calling this unapply. In this case, it's unapply seek because we want to be able to return multiple values later when I'm going to generalize this. Because in principle, a regular expression can have multiple groups, so you want to be defining an unapply seek, not an unapply, because you don't know how many statically there are. With a macro, you could generate an unapply and statically say this is going to give you a tuple of 4 because there are 4 groups in your regex. I don't want to push it that far. So unapply seek is simply a generalization of unapply that I showed you before, which will give you a sum or a none, basically saying, well, I match or I don't match. I guess you can still read the slides, right? I match or I don't match, and this is how many subpatterns that I matched, and these are their values. So this is exactly the same thing as the previous slide. I'm just kind of gradually working my way to something that just looks like method calls, which is another pattern in here that really all this syntactic sugar that you're getting, once you understand the translation, you can just kind of reason back to, well, how do method calls work? And everybody kind of knows how method calls work, so what I'm saying there is that that's really all you have to understand. Method calls and how you get back there, right? So that's what that gives you. And so now the desugaring, as I showed you before, for the interpolated string will look like this. So now we have the problem reduced to, well, I need to be able to call a method, I need to be able to add a method R to string context, because my string interpolator is called R. That was my prefix for my string. And I want to be able to use this in a pattern. So it needs to be an extractor is what we call it, which is just any value that has an unapply or an unapply seek method. In this case, it's going to be an unapply seek. So this is the method that customizes the compiler's behavior and says, hey, this is data. Here's how you decompose it. Okay? So that's the final challenge. This is where implicit classes come in. They make it really easy to add methods to existing classes. So before you would write implicit def, convert blah to other blah, and then take your blah and return the other blah, and then make a new anonymous class. Now, all we really do is say, well, OK, you want to make a new class, and instances of R context are going to be available wherever you have instances of string context, and the compiler is really looking for one of the former and not the latter. That's what we have right now. Well, just create a new class, create a new instance of this class, excuse me, and continue with that. That's what the implicit thing says. It says, make constructor calls to this class implicit. Whenever I have something of type string context, but actually I need something with an R in there, and this class tends to have it. So let's instantiate this class and continue with the wrapper. Okay, the compiler will do that for you. You can do it manually. There's just another desugaring. So there's a lot of magic going on there, but it's not that magical. We tell you how it works. Okay, questions about that? So that's how you enrich your classes with new methods, and that works for everything. I use this for string context, but you can do that for other stuff as well. I mean, it doesn't matter if they're Java objects or anything, really. So now we have our R method, which is that call before that we're trying to get it to compile. We just need to give you something that has an unapply seek method, and it just so happens the regex thing in our standard library is an extractor like that already. So I'm just going to return that. Okay. So implicit class, again, is a little bit of syntactic sugar that encapsulate the best practices that people were doing with implicit conversions. And I think this is something that is pretty safe to use in your own code. I would not recommend writing your own implicit vals or implicit defs unless you're really thinking about this deeply and know what's going to happen. That's why, I mean, and we'll come back to that later, that's why we allow you to disable that feature, because it makes code bases harder to understand. This gives you extension methods, essentially, a cleaner version of extension methods. OK, so I'm going to run this and thus define the rContext clause. And I'm just quickly going to go back and run the original code. So now it says, yeah, sure, that matches. So slightly more dangerous live coding. Let's say we want to capture this group and call it n. Right? So we actually want to get that number out of there. Yes, OK, so we had 10 bottles. Oh, thank you, thank you. Well, that won't get you to a book either, but I will remember your faces. Thank you for clapping. OK, so it does work. OK, yeah, I just want to kind of rant a little bit longer about type inference and value inference, which are kind of unify the idea of, hey, I have this explicit stuff that's required, but really, compiler, you should be able to figure this out on your own. Don't make me type all this. And that's what implicits are. That's what type inference does for you. They're really one and the same thing. And then actually, in the compiler, they're integrated with each other. So implicit search will drive type inference. That's how, for example, the collections are implemented in Scala, so that when you map something over a string, you get a string back, actually, as long as they're characters. When they're ints, you get a seq of ints. This mechanism follows from the unification of type inference and value inference, which we usually call implicit search. So there's a lot of really cool stuff you can do with that. Again, I would tread very, very carefully. But if you want to come back to this, I would definitely recommend Googling any of these things and having a look at it. So really cool test frameworks like Specs, for example, use this technique a lot to let you write really declarative test suites. Looks like I swapped some slides around there. I'm sorry about that. So the final culmination is the one-liner that will let you define a variable n, which is an integer, that's the I extractor that we had before, and get whatever number is in there out. So pattern matching, a pattern like that can be used in any location where you're expecting a variable, not in an argument position, because that's just too weird. But this is just, syntactic sugar for a one-line pattern match that matches this pattern and then gets the variable out and puts in a new local variable. So now that we've implemented this, that works as well. OK, so now you just get an n. It's actually an integer because we wrapped around, like there's this subpattern now that's an integer that takes a string here and says, oh, is this parsable as an int? Yes, then match. Otherwise, no, you're going to match error. Yes?
And if that string, if the expression had two variables, we would get back a tuple?
Well, I don't know. I think so. I do know. I think it works. Let's see. Sorry? Yeah. I'm just going to copy paste if you don't mind. Scroll around a little bit. We're just going to call this M because I'm just that imaginative. Can't see my cursor. It doesn't help. Oh, I'm at the beginning. Sorry, this is like extremely. Actually, I'm using CodeMirror for this, and it's really pretty cool. So I'm going to call this other variable M. I didn't mess up anything else. And then I'll just put 11 in there. And there you go. So yeah, so it just generalized like that. I was a little bit worried, but I'm pretty sure I implemented that correctly. OK, so this is all pretty crazy when you apply it like that. But think of a domain where you work a lot with decomposing unstructured data and making it structured and making it typed again. And would you rather do that in one place where you kind of see prototypically what you're expecting and getting like the holes out of that immediately? Or would you rather just, I don't know, compose a lot of function calls and say get first hole, get second hole, and so on? So again, you have to use these things judiciously. depending on what you're implementing and where you are in your project. But I think this is pretty cool stuff. So other people think so as well, and they're implementing quasi-quotes and stuff like that with it. I guess a lot of people say, well, Scala got a lot better. Actually, I have no idea how I'm doing on time. Okay, so when did we start? Sorry? Okay. Well, I don't have too many more slides because I've been talking really fast, so I think it's going to be okay. But just so you know, feel free to ask more questions. So yes, Scala 2.10 got bigger. Can you consider that simple, or is that really becoming complex or complicated, or should it be simplistic? Should it really be like, oh, this is a string interpolation, we just bolted this on for you, and sorry, don't pass it around, don't define your own. We're not going to do type inference in those. Oh, we have macros as well, but yeah, you can't use those with string interpolation. I mean, I guess you kind of see where I'm going with this. From my opinion, when you're learning a new feature, that's a big investment, and you want to get as much bang for your buck as you can get. So when you learn a new feature like that, you really want it to integrate with all those other features. And I think that's what we're doing with all these Scala features that I've mentioned before, is we don't just like bolt everything together. We actually spend a lot of time thinking about how this can be reduced to what Scala really is about, and how that once you understand this mechanism, it becomes intuitive for you to use it. And I'm not claiming we're perfect, but that's what we're striving for. So, and I guess the main point there is that since these are all method calls, you can develop your own libraries where you can use this mechanism and define what makes sense to you. So I've kind of focused on like the new sparkly things that are in Scala 2.10 that I'm excited about. All of the stable features that you're using every day to develop your applications, those were in 2.9, those were in 2.8. That's not what this talk was about. I just want to I want to emphasize that we're, despite all this cool hacking in there, the first thing on their mind is, we're a pragmatic language. People are getting shit done with it. So Java interop is important, balance it against making programming fun. Not an easy thing. Legacy, Scala is 10 years old. How do you balance that with sanity? People want new toys. How do you balance that with simplicity? So this is where we are right now, and we're really looking forward in 2.11 to further simplifying and making Scala faster and smaller. But this is really very much our drive. So we're also pragmatic in the sense that we don't say, hey, immutability is the future, multi-core is the future. We believe that. But if you want to mutate, that's fine. And a lot of times, locally, your method will look cleaner if you just mutate. Just don't do it at a large scale. It's not a good idea. So, for example, Scala has this new neat futures concept. And you're saying, well, let's unify mutation and asynchronicity because we can unify things in Scala, right? So I hacked, sorry, this is red. This is bad. This is a var. And I specifically hacked the CSS to show red for vars, even though sometimes they're okay. And so, you can do this. You can write a future that writes 1 to y, and you can write a future that writes 2 to y, and then you can run it a couple times and see what values you get. That's not recommended. And we make it really easy for you and seamless to write code the good way, and that's what you should stick to. I guess the point that I'm making here is that it's really not up to Scala as the language to say, hey, you can never use mutation. That's something that you should decide for yourself. So maybe it would be simpler if you just disallowed this, but sometimes you can get an extra inch of performance out of there. So sometimes you get 1, sometimes you get 0, sometimes you get 1 again, sometimes you get 2. It's fun, but I wouldn't do it. Oh, yeah, no, I went to the wrong direction. Right. Sorry about the flickering. Just got me all confused. Right, so futures. Since we're on the topic, I'm not so much of a asynchronous kind of guy or distributed computing, but futures are really cool because they're like monads, is what you'll hear on the Scala mailing list. Wow, we don't care about that. I'm serious. We really don't care. It's great that whenever you see future in there, it makes you think twice, right? Is this actually going to be available in the future? How long is it going to take me to get this? This is something where types help your programming and say, hey, think about this. This is going to take a while before you get this. Maybe you'll never get it. Maybe there'll be an error. Usually, types get out of your way. I've specifically omitted a lot of the types in the presentation to show you that you don't need to write them. But a lot of times it's good to think about them and say, oh, this is a feature. And this actually give you a lot of nice syntax. So this is what you get with features. You can say, well, I'll do this, and in parallel do that. And then when they both come together, fuse the result with some magical plus operator. And now with Scala Async, which is not technically part of 2.10, but it's built on top of 2.10 and macros, you can write it even more succinctly. So there's this async keyword, which is a macro. And you just write in direct style. You just say, well, I have this feature here, and this other feature here, and now I want to wait for the result of that, and await the result of that, and then when I get them, I'm just going to combine them. So no more funky arrows in your fors, and when do I write the semicolon or not. I quickly just wanted to say that, like with all these complications here, you can actually disallow some of the features in there. So SIP18 helps you keep it simple. You can say, well, I don't want any postfix operators. I don't want any reflective calls, which made you incur some runtime overhead from structural types. I don't want to let my programmers as a manager define implicit conversions. And there's a whole lot of other things. So for example, we have this dynamic trait where anything that you want to call in it is fine. And that you do by extending dynamic. And then whenever the method isn't defined in that thing, it's rewritten to an apply dynamic call. I won't go into it since I'm running out of time. But then you can fuse that with macros and actually, again, statically say, well, this is a valid call or not at compile time. I encourage you to Google for this kind of stuff. I love it. It's great. I'm doing it on a Sunday afternoon, whenever you have time. So on 2.11, our focus is very much on making it smaller, faster, and stabler, like the Daft Punk song, roughly. And so we're modularizing the standard library in the compiler so to get your contributions more readily for the interpreter or Scala doc or our testing infrastructure will be spun off to different projects. We're very much at work. Greg, who's working on incremental compiler, because batch compilation in Scala we know is slow, but there are a lot of tricks you can do with incremental compilation, and we know how to make that a lot better to give you a much better experience in in IntelliJ, the Eclipse plugin, Zinc. There's Maven plugins for that. SBT uses that, of course. So that's another component, Zinc, that we have spun off and are improving, and that we're happy to work with everybody who wants to integrate that, and just get simply better batch performance. Mm-hmm. And so I kind of put that in there to go out with a bang. This is my last slide. So yes, the default target will be Java 6, but we're working on a Java 7 and 8 backend that has a lot of clever tricks using invoke dynamic for interoperating with SAMs in Java 8 is something that we can do while compiling to Java 6, for example, but leveraging their performance increases probably not going to happen until Java 8, and that's going to be Scala 2.12. So if you want to participate in that debate, sorry, too late. 2.11 is coming out in about 6 months. But I think I'm pretty confident Java 6 is going to be around for a little bit longer. And we'll be ready for Java 8 and 2.12, which is only about a year away, year and a half. So thanks a lot for your questions during the talk. Time permitting, happy to take more.
Thank you, Adriaan.
Thanks.